Hello, I'm going to try to draw an ellipse on a piece of paper. I'm going to use this cardboard box and some screws, and I'm going to drive the screws into the cardboard box through these papers. All right, so let's see how that goes. Okay, so we're going to start. Let's see if I can get this in here. I don't know if I can. Oh, it's going. Okay. And I want to make sure I don't drive the screw into the tabletop. But I think that's fine right there. And the screw is not in the tabletop. Okay, and now we have a second screw. So let's put that about here. Oops. Let's try to get that started by hand first. So we'll try that right there. Here we go. Okay, so, and it's moving around, so that means that those screws are not into the tabletop. And so now let's take a piece of string, and we're going to tie a loop, but I want to test this out to make sure how long the string has to be so that I can keep the ellipse on the paper and in the screen. That looks like that length right there is just about perfect. So I'm going to tie this loop here. There we go. So there's our loop. That looks about right. So I'm going to trim bits of this. There we go. And then take off this long part. There we go. All right, so we've got our loop. And then we need a pencil. So now let's see if we can pull this string tight. Oops. Like this. And I think that pencil is too smooth. Maybe we'll try a pen instead. Like this. So let's go. Okay, and that looks like we have an ellipse. So, let's do some measurements in the metric system. Okay, so this is a focal point, and this is a focal point, right? So those are the foci. This is one focus, second focus. Okay, so here we have one end of the semi-major axis, and there's the other end of the semi-major axis. And it looks like the semi-major axis is 15.2 centimeters. That is the semi-major axis. All right, so now to find the semi-minor axis, we would have, or rather, that's not the semi-major axis, that's the major axis. What am I talking about? Okay, so that's the major axis. Okay, and then the the minor axis rather would be perpendicular to this and exactly halfway between the two focuses, the two foci. Okay, and so it looks like that might be about, that's not going to be quite right. It looks like it's about 14 centimeters. So I'm going to write that down. Minor axis, 14 centimeters. Okay, now the distance between the two foci the two foci looks like it's about, I don't know if you're seeing it, but it looks like it's about halfway between these two marks. This is 5.4 and 5.5, so that would make it 5.45. So we'll write that down up here. 5.45 centimeters is the distance between the two foci. Okay, now we need to know where the center is, so we're going to divide that number by 2. So we'll pull out the calculator. And we'll do 5.45 divided by 2 is 2.725. Okay, so if we measure there's 725, it's about right there. That looks like that's about the center of the ellipse, approximately. Maybe a bit more over. Maybe a bit more over this way. Okay, so we've got the center of the ellipse, approximately. Okay, now, according to Kepler's first law, planets orbit the sun like this, around an ellipse, and they and the sun is at one of the foci, so that means that the sun could be here, right? If this is the sun, then that makes this the perihelion. And it makes this point over here the aphelion. Okay, and Kepler's second law says that as the planets approach the perihelion, they move faster, and as they approach the aphelion, they move slower. So they speed up, slow down, speed up, slow down. Okay, so that's enough for this video, and hopefully this will help you to figure things out.